Shall we wait for some more time? Because I see, is everybody here? I see 7 people joining. You tell me, yeah, when to start. I will just share the presentation meanwhile. Please let me know when to start. Do you see it? It is in full mode. Do you see it? Oh, it's although it's in full mode. Okay, all good? All set? Okay, good afternoon, everyone, and or good morning or good evening, depends on which time zone you're attending this workshop. Thank you for joining. It's also a pleasure for us to deliver this workshop. We have been preparing this for quite some time, so we are excited to share this with you. I am Babita. I work as a postdoc bioinformatician at European Genome Phenome Archive at CRG in Barcelona. And I will be presenting together with my colleagues here a bit about Beacon and then share with you the hands-on session. So, okay, oops, but it's okay. Is it all okay now? Just to briefly give you, as what we have planned today for today is to give you a brief introduction first about sensitive data and what are the challenges we are facing, especially in biomedical community, and then Beacon, how Beacon fits in the picture. Then Jordi will be there to give you a bit of brief about Beacon API. Mauricio will be there then to take over and give you introduction about reference implementation. And then together we will all assist you in the hands-on session. I also want to thank other members and hosts here are now Alish and Lauren that were also crucial for preparation of this workshop. So let me start with sensitive data. So sensitive data, human genomics data is, of course, it's sensitive. It's like our fingerprints. I would say that it's more confidential or more sensitive than fingerprints because it is kind of, it tells you about your family tree. It tells you about your medical history, not only about yourself, but also about in your future generation or your past generation. So how much you take the control of your own data, your own genomics data is something like debatable in the community. Like how much do you have control over it? And that's why this is the first slide for me is because this is crucial to address this. Because what is happening now is because of this challenges around sensitivity of this sort of genomics data, biomedical research is facing a lot of problems, especially about now with AI and machine learning technologies, catching up. Many other advanced data analysis tools has been created, but because of lack of data, the biomedical community is not able to utilize its full potential, like I don't know other entities are doing, Facebook, Google, whatever. They are playing with the data set, but we lack here. So this is something I to challenge here. Now moving on to other aspect, which is this. I'm taking it from this paper published by Ivan Burney in 2017, and it was predicting about healthcare data in research. So far, what the data that we are seeing is mainly comes from research and not from healthcare or clinical or medical data. However, also I was attending 2 days ago the talk. Medical healthcare data is very important because it brings the heterogeneity, it brings the real patients' data, it brings it brings the sophistication of machine learning tools require for the data in the data sets. So that's why this is one of the prediction that Ivan Burney did in his publication, which was like in 2012, only 1% of the data in research was coming from healthcare. By 2017, it became around 20%, and in by 2022, it was predicted to be grown to 80%. So 80% of the healthcare data would be coming from the clinicals, from clinicians, from hospitals, and then he also mentioned the challenges to deal such sort of healthcare, such data from coming from the healthcare system. So we are in 2022. The prediction of 80% of the data coming from healthcare system, we can say it's not true yet, but we are moving towards it, which is inevitable. But are we ready to face the challenges? So just to describe briefly, what are the challenges he proposed or he mentioned in this paper? It was about geographical distribution of the data. Now with the GDPR in Europe, it is one of the steps is not to, so the data should not leave the physical or the geographical premises, and it should be tightly regulated. It should not be it should not uh, it should not be given uh, exchange between the servers, etc. Then we have data access and dynamic challenges. So, what sort of access levels we want to provide to this data set? Who can access? What sort of privileges or privacy we want to provide? Clinical data. One of the biggest challenges with clinical data is that it is not interoperable, especially countries like European countries where everybody speaks. Every country has different language, different way of storing the data. How to mitigate those challenges? The medical community is also not equipped to store such volume of data sets. Technical challenges, of course, we are talking about hospitals. They are not technicians, they are not bioinformaticians to deal with the data sets and challenges around that. Then, of course, the attitude and action towards open data. We are not still addressing what to do with such sensitive data, um, how to make them private, but at the same time make it open enough so that the maximum output can be taken from such data set. So we are not addressing these challenges yet. And then, of course, secure access and governance. So these are the challenges in the nutshell which the healthcare data brings with itself. And then at European Genome Archive, where I work here, we are trying to address these challenges from different perspective, by developing tools, by addressing the scenarios around it. For example, geographical distribution data, we are working here with which we call FEGA, Federated EGA, which is basically that you are not now supposed to submit your data to central EGA, but you can create a local copy of the entire EGA wherever your data set is, and then you can submit the data to your servers. So this is again for the data access. There are data passports or AAIs proposed. For interoperability of the data set, there are different GA4GH tools and standards that we are working towards, and like so on and so forth. However, I wanted to say that still the healthcare data discovery is scary. Why I'm saying it's scary is because there are different examples that I encounter when we talk about discovery of the data. So this is one of the examples that I discover. Like on Facebook, there are groups about different people creating groups for the suffering of patients who have certain genetic mutation and they don't know where to go. They kind of create this sort of group so that they can talk with each other or catch up what is going on in the research community. So on one hand, we are talking about sensitivity and privacy of the data set, and people should not, how to protect those peoples and people. On the other hand, there are, this is the reality that we have this sort of groups that are due to lack of, I would say, information, or where should these people go, or how should these people discover a patient like themselves, let's say, without, with their own privacy. Other scary factor is that I don't know if this is the reports that I've downloaded from internet, but if you have gone to in your hospital system to go for certain sort of genetic analysis mutations, the reports looks like this. So it is very, there is no consensus on the how to write the report, or what sort of they are stored in PDF. First of all, there is no server or centralized or any database where this information could be submitted, so they can be extracted or quickly searched on, or or at least a general template, so that even if we want to extract such data and put it in a database, we can access it easily. So this is another challenge, that there is no common consensus yet how to store such data. Then another challenges, as I mentioned before, is this Tower of Babel sort of. It's like every you know everybody is speaking their own language or storing the data in their own style. So how can we share or pool such data together to utilize it in the research, or further get advantage from the such data set? So this is one of the recent OMOP or common data models are coming into the picture now very slowly. It's They are trying to transform all data from different resources to one data model, so that the querying on such models would become easier. This is, however, very slow progress, but thankfully it's there. Then another issue is that hospitals usually do not talk with each other. So not I'm not even talking about different countries hospital. Is the some same countries, in the same what do you say, province, the hospitals are not talking each other, and this is one of the challenges that was um, um, presented to us from the clinicians that we were participating, or we are participating in a collaborative project. And we talk with them and what are the challenges for them. And this was one of the challenges that was highlighted to us, that even within these networks, for example, this is the network of Catalonian hospitals, they are not sharing or talking with each other, as in, I saw this mutation in this patient, for example, and this was our diagnosis. Did you see such same mutation or same patient profile in your hospital, or what was your diagnosis, or what was the prescription? So this kind of information, which should be very basic and easily available, which is also not happening. And to continue it further, one of our colleagues, Delia, I asked her to provide some inputs for this workshop, because she is also the partner in La Maratho grant, and I wanted her to be here, in fact, to talk from her side the clinical challenges. So she couldn't, but she sent me a note about different challenges. So I'm highlighting just a couple of them here. Which is, for example, she says, we have had a lot of problems regarding the data protection and privacy of data in terms of sharing. Even though it is clear that the privacy of the patient is not at risk, it's difficult to understand the legal responsibilities of the different hospitals. Another challenge is that the technical limitations of the hospital. Not everybody, or not everyone has all resources available. For example, in general, there are no previous databases to start with, which makes sense. For example, these are the challenges that a clinician, a medical doctor, should not be facing. It's not their role. So of course, there should be some entity involved there for reutilization and maximum utilization of the data set that is being generated at the hospitals. However, right now, because of lack of such practices, the clinicians that are facing such challenges. So what are the possible solutions, and which right now, how we are tackling this? It was none. We still see all of the challenges that I presented before. So before starting, I would like to say that it's like looking in the dark to find solutions. This is a quote which says, from a physicist, which says, "Those who explore an unknown world are travelers without a map. The map is the result of the exploration." So this is the premises with which the Beacon project was born, or the pilot of the Beacon project, which was version 1. Oh, before that, sorry. What I want to mention is we want to also shift the focus. So from centralized knowledge discovery, which is the challenges what I showed before, all of that mostly consists to what is the privacy, how to deal with that. So this is the before scenario, which is to query the data. The data is submitted somewhere centrally, and you're querying in the data sets. And this is where the clinicians usually are not able to participate. So what we are trying to do is to shift the focus, which is decentralized knowledge discovery. So instead of the data coming at the central place, it should be the query that should go to several data stores. It shouldn't be other way around. So with this, what we are trying to address is first the challenge of this clinicians that are scared what to do with the privacy. We don't know what are the legal constraints. So at least with that sense, you are not. I mean, your data stays with you. Is that our query should reach to your data and ask this question. So given that, yeah, the premise of the first pilot project of Beacon was launched in 2018, and this was in collaboration with this Global Alliance of Genomics Health, GA4GH. And the basic idea was simple, that given we will not touch the data, it's only that we want to make a query that do you see this mutation, for example, at chromosome 13 at this position? And what I would like a response would be yes or no. So do not tell me, what patient or whatever disease. No, we would like to know if you have certain mutation or not in your data set. And the query, that query will be returned to the user, and the user will be able to, likewise query in different data sets. So this was the first premise of Beacon project version 1, and it was successful. So it was tested, this pilot project, and we could set up the models or minimum requirement that should be there for utilizing such tool. And then from there on, in 2022, now it was the Beacon version 2. We started working towards the Beacon version 2, which was like first after the successful trial, how can we extend the information? So what more can we ask? So before it was just tell me the mutation, yes or no. Now we started including some more, information like biosamples, individuals, genomic variation, etc. To give you a bit more detail about this, just you know like how it looks. So this is the conversion 1. So before it was like, do you see a mutation on chromosome X or at this position? And would return yes, and that's it. There would have been no response. And then after we conversion to launch, what happens is that we can ask, okay, if you see this mutation, could you tell me what diseases it belongs to, or what sort of disease has been organized, or do you have all information about phenotypic or studies information or value denotation, etc., etc. And also you can ask, how can I access those data set? How can I apply? Beacon will tell you who to contact in such scenario, and then you can extract or contact the people who, if you're interested to ask for the data set, etc. So this is the main difference between V1 and V2. And the V2 is mainly what the models that we have created is your typical genetic testing. So what happens during genetic testing is, it's a basic, you go for biopsy, sample preparation, DNA preparation goes towards a machine, results and analysis, you apply some algorithms there, variant calling algorithms, for example, and then you extract whatever variations you have, and then if there is a medical interventions or other downstream process. So this is the genetic testing, and Beacon version 2 was based on these models. So what I mean by model is that, like individual, for example, what should be the common or minimal information, for example, gender, ethnicity, age, country, etc., etc. So that will come to individual. From the biosample preparation, where this biosample belong, etc. What everything around the samples that was taken, run, for example, what sort of machine it was used to run the experiment, or was it whole genome sequencing, RNA-seq, or whatever data it was. What were the tools that you used to call, or what sort of aligner there was, pipelines, variant callers, etc. Then to extend it further, for example, with bigger data sets like cohort, you can also query about cohort in Beacon, or a different data set. For example, you're looking for all studies belonging to muscular dystrophy. So you can also query based on the studies. And the genomic variant, of course, which is, like what chromosome, position, start, end, etc. So these are the different models that Beacon V2 has, where you can enter your data, or you can map your data to these different entities. And basically, so what happens is then, so these are your data set, for example. Then what we call, you can beaconize your data. So what we will learn in this hands-on session how to beaconize your data. And what will happen is that if you are this entity, for example, you can light a beacon on top of your data set. So that is the idea of this. So this is one of the pilot project that I mentioned before, funded by La Marato, that we were running with 6 different hospitals of Catalonia. What is happening here that each hospital is lighting beacon on their top of their data set, and the idea is that we create a network of those beacon, and then a single query should be sent to the network, and then the response should be aggregated and shown to the user. In this case, for example, any clinician who has found a new mutation profile in their patient should be able to ask different hospitals, do you see similar profile or in that case, what was the diagnosis, or what did you do, what did you recommend, and then this response the clinician should get back. Again, beacon network. Where we are going with this is to create these different beacons, to organize them in beacon networks, so all over the world. So there should be different pings, like wherever the beacons are lit on the data, there should be pings like we are here, talk to us, and then a common query can be sent to all of these different beacons around the world, and then response can be aggregated and shown it to the user. I was talking about the privacy and access levels. So Beacon comes with this sort of granularity. So, for example, Beacon provides a public open version, which will be just Boolean yes or no response. So you can choose to not show all of your data set, to to say yes, I have what you're looking for. I have that. For more whatever to know more, contact us. So that would be the public beacon. Then there is a registered account. So, for example, somebody registered with their institutional ID, you can show them more results depending on your choice. So it will be like, okay, I have this data, what you're looking for, and I have like 123 cases about that. And then there is controlled, which is like once you trust this person, or you have given proper control to your data set, it can show further detail of the data. So this is based on, you can choose which type of beacon to light on your data set. It's completely the data, the control will be completely in your hands. This is one of the examples with the training UI. So how it looks in the UI. So this is one mutation. For example, I'm searching here on chromosome number 22 at this position, if C is changing to T, and I make a generic query. In the public version, it would say yes. It's a Boolean response. Yes, I have this data. Then, for example, if I want to click and look for more, it will tell you have to be logged in or other response for the control access. If in the full version, if you have if you have checked all the control access list, in the full version, it will be this information about more about what can be added. Sorry, let me check the time. Okay. There are different entities, different institutes that have already tested and beaconized their data. There is a beacon verifier tooling. Once you light the beacon on your data set, you can use this tooling to see if everything went well, if you're all correct, and then this will be added on the beacon network. As I said before, this beacon version 2 has been just recently accepted in April 2022. It is the first specification for genome data discovery. It was approved by GA4GH. This is Jordi Rambla, our PI, who was presenting in this to the community. He was explaining what beacon is and what it can do. And after the common consensus, it got approved. Further, just in a nutshell, our idea where we want to take this beacon would be to make it as intuitive as you go to Google to make a query. So it should be as intuitive to write, what sort of mutations you're looking for, or what kind of patient profile you're looking for, and in which age group, etc. And it should return you some response as easily as Google does. And of course, to take it further, it would be to create this sort of internet of genomics. So all sort of genomic queries should be done on the beacon. This is from my side. I would like to really thank you. It's a big team, beacon team. There has been many collaborators, the main developers and the testers, and GitHub commenters. So everybody participated in this. It is a mammoth project. And thank you for the beacon team to be involved in this. And thank you for attending. Thank you for the funders. Thank you for ETA. And I would be happy to take questions now. Thank you.
Thank you, Babita, for this beautiful introduction to what is sensitive data and the different aspects we should be taking care of, and how Beacon fits inside this context. Okay, so my role today is just going one step further and explaining a little bit how we have done the things that you have already shown in some presentations, in some slides. So this is the Beacon project in GitHub. The ones that are familiar with these development technologies should recognize that this GitHub here, and also the different folders that are around. So the main things to understand here is that the Beacon API, what we call the Beacon, the approved project from the Global Alliance, is mostly divided in two big blocks. What we call the Beacon framework, that it's mostly the way that the client, meaning the application, the software that it's running on the user side, and the server communicate themselves. Okay? So it's mostly telling you how do you do the queries, how do you get the results back packet, and how do you get these kind of things. Yeah, so this is, sorry, because this is not what you see in the open API. Sorry, I'm using a very small screen right now, and this is making me a little more harder to show everything. Okay, so what you are seeing here is the code that it's, or the schemas that is are telling you how to do the query, how to get the request, independently of what you are querying about and what you are getting the response about. So the framework is designed in a way that you can query about genomic clinical diagnosis, as Babita explained, or if you are interested in plant genomics or in viral genomics or something like that, you can have other models, not the ones approved by the Global Alliance so far, that are capable to run on top of the Beacon API, in particular the framework. So the framework is like that, and it has two types of endpoints. This is designed as a REST API, meaning an API, an HTTP API that you can query and get the results back, and it's having two big blocks of endpoints. One of them we call informational endpoints, that it's telling you things about a given Beacon instance, and then the configuration endpoints that is giving you more details on that. In particular, which are the models that are supported, which are the entry types, how this beacon is configured. This is where you know about if this beacon is public or not public, accepts only Boolean responses, or also other types of responses. So this is the framework. The framework is just these endpoints for doing that. And then we have the model. And in the models, we can have different models. This is the default, the Beacon B2 approved one, default, the one that Babita was showing before. And you can recognize here, although Babita has run quickly because of the time limitations, the different elements that Babita already mentioned, from individuals to the biosamples, to the analysis runs on, the genomic runs, sequencing runs on them, the analysis performed, and then the resulting genomic variants, and also these organized as data sets or cohorts in the case that this is decided by the Beacon owner. So for each one of these entry types that not all the beacons should implement. So one beacon could implement only if they are interested just genomic variations, or just cohorts, or just individuals, or a couple of these endpoints. So it's not required that you include everything in your beacon to be Beacon B2 compatible. So for each one of these things, you have a set of endpoints. And in this case, these are the endpoints of, sorry, now it's failing. Why? Because I'm in the initiation one. Okay, 1 second. Because I have it open before. Oh, come on. I've been mangling with that for half an hour before. This is the previous one. So let's change that one. I detected something in my local copy before, but let me look for local genomic variations. Endpoints in JSON. And if this is working wonderful, we will get it. Okay. So here you see, for example, in this specific beacon instance, that it's having the world model as we have defined it, which are the endpoints. You have both the get and post endpoints. Both of them are equivalent. You can see that this beacon in particular has one endpoint that is called G-variance, that is giving you the whole list of genomic variations. You have one endpoint that allows you to query for one specific variation, or you can query for this specific variation, which biosamples are having it, or from this specific variation, which individuals are having that variation. So these are the way that the REST API usually is modeled, and this is the approach that Beacon V2 is doing. So Mauricio will show later a little bit more better the Beacon UI, but just let me show you this thing. Here you can see the same website for testing beacons that Babita has shown. And in this case, what we are seeing here is just 3 beacons in this case. And the information you see, all of it that you see here, comes from the beacon themselves. So we have nothing hard-coded except the list of beacons that we should look at. For all the others, for all of the information, what we are doing is pinging the informational endpoints that these beacons are suggesting or having, and getting all the information from there, including the logos. So everything is there for a beacon client to get the information and use it, show it, organize it as it says it. And in this particular case, you can see that this progenetics beacon from the University of Zurich is in, because everything is green, it means that it's implementing all the endpoints. In this other case, one test beacon that Senac was lighting up some time ago, the ones in gray are endpoints that this particular beacon is not implementing because whatever the reason, they have not implemented yet, they're not interested in these endpoints in particular or whatever. And so you can see this other one from the University of Leicester that also has several endpoints that they have decided not to implement for this specific beacon instance. So this information is coming from the informational endpoints. And then we have this other way of looking at the API, if you want. This is just one client again of the beacon server API, and this is the different endpoints organized in a different way. This is the genomic variance endpoint. This is the genomic variance, but querying for regions one. This is the information about individuals and biosamples, and this is information about cohorts. So this particular beacon is having different things, and one of the things this beacon is also having in the phenoclinic query is the list of filtering terms. Is another of the informational endpoints where you, as a client of the beacon API, could pull the list of terms that this beacon understands, or the list of terms that you can use in a query. So, for example, I was interested in females with coming from Northern Ireland. I don't know if we have any in this case. I copy that thing, I go to the training UI, go to phenoclinic, and then paste this thing here and do the query. And we should get some results. In this case, as I'm logged out, I will say nothing. But if I log in, I could see how many users I have, as Babita mentioned before, and also the details of each of these individuals because I am authorized. So you can see that this information that I showed before, this filtering terms, is coming from the beacon. So I know as a client which queries I can do in this particular beacon. So this is the overall organization of the API. You have one framework that is allowing you to know how to send the query and how to interpret the results in terms of overall block, meaning if this is a count, if this is a Boolean, this is a details, how many rows you are getting per page, all these kinds of things. And then you are getting these informational endpoints I was meaning, and then you are having the the model where you are modeling different things, the ones that make sense for you, and this everything in Beacon should be kind of self-descriptive. This is one of the ideas of that. Given that if it's not that way, then it would be super complicated. First complicated thing would be to make everyone use exactly the same API, meaning that all of you should be Boolean, then will be not enough, but all of you will go to record level details that many will not be able to do so. Others, if we mandate everyone to implement all the endpoints, many will say, I don't have this information, so I cannot share it. Not because I don't want, it's because I don't have it. So we need to provide flexibility, both in how much you want to disclose, depending on the type of your project, also which information do you have and you can disclose, and all these kinds of things. Yeah. So this flexibility makes the clients, as the one we are showing before, the one from the registry as an example of a Beacon network client, that we need to make these clients aware of the heterogeneity, the differences in all of the beacons. So all of them should be self-descriptive and are helping these clients to do their job properly without making the user crazy. So with that, I will finish. Happy to answer any question that you have in the chat. And also, now I think that Mauricio will tell you more about what we are doing in the hands-on session, and also how you will populate something that then could be leveraged by clients like that. This is not part of their specification itself. It's just one client that we have built for demonstration purposes. The API itself is what is officially approved by the Global Alliance. So with that, thank you very much. And Mauricio, the floor is yours.
Thank you, Babito. Thank you, Babito. Thank you, Jordi. So let me start by sharing my screen. Okay, perfect. So in this part of the session, we'll be going through some very quick concepts about the Beacon reference implementation. And then we'll start to do our hands-on session. So we will take 15 minutes to learn a little bit more about the Beacon, what is the reference implementation, and some examples of the Beacon reference implementation at the EGA. So the Beacon v2 is a specification established by the GA4GH that defines an open standard for federated discovery of genomic and phenotypic data in biomedical research and clinical applications. The current version of the specification is v2, and it consists of two components, the framework and the models. The framework defines the format for the requests and responses, whereas the model defines the structure of the biological data response. So the overall function of these two components is to provide the instructions to design a REST API. So we can consider that if the Beacon v2 is the language, the framework and the models would be the syntax. So the Beacon is an API. The Beacon started as an API that would respond to a simple query. Do you see C? Do you have C at chromosome 13 at position of this position? And the Beacon would respond a simple yes or no. However, in the Beacon v2 model, the Beacon can now offer more detailed queries and more detailed responses, especially taking into account the phenoclinic data. So the CRG mission regarding the Beacon v2 was to create a specification. So we have a clear difference between the framework on which the API is built and the models, which contains the structure for the biological data response. And the Beacon team is wide and complex, and we'll be mostly talking about the work that has been developed by Roberto Ariosa and Manuel Rueda. So which are the implementation options that we can have for a Beacon? So on option A, it's suited for users that have the data organized and structured in a database, for example, SQL or NoSQL, which may or may not have an internal layer to get access to it. So let's say that you have the resources and the knowledge to read the instructions, meaning the Beacon v2 specification, and to build an API on top of your existing solution. So in this case, this is the option for you. this is what we call the Beacon V2 API implementers. And as we seen in both Jordi and Babita's presentation, we have a couple of them already in the Beacon V2 service registry. In option B, let's say that you have a solution to organize your data, but you don't have the resources or knowledge to implement a Beacon V2 API by yourself. So in some pilot studies, the CRG has been helping individual institutions to build their own Beacon V2 API. However, this option is not practical and does not escalate well. So let's check option C. So in option C is what we call the Beacon V2 reference implementation, where you have your data somewhat structured, for example, in Excel files, PDFs, VCFs, or even in an SQL database or an EHR solution with some phenotypic information. So you want to beaconize your data or a subset of your data to be part of the larger ecosystem, but you are unsure where to start, or you don't want to invest a lot of resources because you are still unsure if the whole thing will pay off. So most centers are in this situation. For this reason, we have developed the Beacon V2 reference implementation. So what is the Beacon 2 reference implementation? It's a free open source. It's Linux-based. It's a Linux-based software package that allows to light a beacon out of the box. It's been funded by Elixir. It has been developed by EGA-CRG, by Manuel Rueda and Roberto Ariosa, and it can be you can install it locally. And now available through some containers that we will use in the hands-on session. And it's a tool that is a command line interface. You need to install Perl, Python, and Bash, some libraries in Perl, and it should work out of the box. So the Beacon reference implementation has been just recently published. In this publication, we'll find more information about this tool and the software that we will use in the next working session. There are four main components for the Beacon 2 reference implementation. So we will work with some tools that will load that into the database. Will mean that we'll load some metadata and some genomic variants from the VCF file. We will have a database, which in the Beacon reference implementation, we will work with MongoDB. We will have a query engine, which is our API, and we will use an example dataset that has been provided by our partners, by Cineca, which is the 1000 genomes dataset, a subset of the 1000 genomes dataset, and that is populated with rich phenoclinic metadata. So let's take a look at the tools for loading the data into a database. So we'll focus on the metadata and the genomic variations. So first of all, we will transform the metadata. Then we will transform the genomic variations and we will load the data into our Mongo database. So this is our data ingestion steps. So for transforming this metadata, we will first start with a spreadsheet. We have provided a template, and we have already populated a template for the purpose of this workshop with the 1000 genomes data for 2,504 participants. So we will use the tools to transform this metadata whose input is a spreadsheet format into the Beacon-friendly format. So let's take a look at the files themselves. So this is the template that we will use. Oops. So as you can see, you can find here the 7 different models, including, let's just hide this thing. Okay, so as you can see here, you find the 7 different models that that has been shown by both Babita and Jordi. And this is currently on a flat format. So we can populate this, and this file, this spreadsheet, will be validated by the Beacon 2 reference implementation functionality called the Beacon validator. So here we can see some fields that will make sense and that you can populate your metadata with. And now let's take a look at the populated metadata, which we will use for the purpose of this workshop. So this is the metadata for the 1000 genomes project with rich metadata provided to us by the Cineca project. So as you can see, we have some flat attributes. However, we can also go to individuals, and we have some complex hierarchy represented into a flat file. So furthermore, you can also have your genomic variants. For example, as Babita presented in her slideshow, some of this metadata is stored in PDFs or in other formats, and we can actually try to populate the spreadsheet with the genomic variation data, and this will be validated against the reference schemas. Okay, I don't want to save, so let's go. Here we go. So, share. Oops, apologies, it's a slideshow. So now that we have taken a look at the spreadsheet and we know a little bit more about the content, the idea is that we can transform some of our metadata, or the majority of our metadata, into the seven entities that compose the beacon models. So as you see here, we can find the Excel sheet with the 6 models, plus 1 for the genomic variations, which will be, for example, used when your data is in a PDF and you don't have the VCF for this data. We'll use the beacon-friendly format, and we will validate a data that is inside the spreadsheet against the reference schemas. And we will also create the beacon-friendly format files, which in this case is going to be an analysis, and it's going to be analysis in a JSON format. So this metadata transformation is crucial. So we have some cons and some pros of using this middle file to transform from one format to the beacon-friendly format. So one of the cons is that the users have to map their own terms to the beacon v2 default schemas to enable the queries between the database and the API. Some of this metadata has some deeply nested structures, as we have seen in individuals, so some bumps are expected. And this is a suboptimal option if you have the data already structured in a structured format, such as OMOP, CDM, FHIR, etc. So as for the pros of using this spreadsheet for the metadata transformation, we will have some consistency between the databases to the queries and the responses, and the metadata will be validated against the Beacon v2 models schemas. Documentation is available on how to populate and how to create this spreadsheet file. And you can also skip this intermediate file and map directly from your data to the JSON beacon-friendly formats. So we will do this on our workshop in a little bit, but this is the expected result of a file that has been correctly validated. So now that we have our metadata, we need to transform our our VCFs to a genomic variant format. So as I mentioned before, we can use the spreadsheet template if our data is in some PDF format, but we can also use some VCFs for this conversion. So our input VCF can be any version higher than 4.1, either single or multiple sample. No G VCF for the moment. We can use multiple genome references, such as HS 37, 19, and 38. And one of the first steps that this utility does is it splits multi-allelic variants to biallelic. Then it goes on to the re-annotation with a SNP with 3 databases. So our objective here is to serialize to JSON your VCF. We will use the functionality beacon VCF, and this is an example of the beacon running and the expected output. We will also do this during our workshop. Finally, we will load the data into a Mongo database. To do this, we will not use this functionality, although this is present in the MongoDB, because for the purpose of this workshop, we will do it from our local host to a container that is running our Mongo database. However, the beacon tools allows you to load that the beacon-friendly format into the Mongo database. Finally, data is already ready to be accessed by the API. So we have included an API, and we will use this API on our demonstration. The API can be configured through a config file in different levels of security and granularity, and then we'll try to do some get and post requests against this API. We can also use request parameters and filtering terms to execute queries. So this is an example of a tool that is running on top of the API. This is the beacon training UI, and that has already been shown by Jordi and Babita. And we will also do some queries using this software. So the idea here is that you can execute queries on top of your API, and you can get, for example, a Boolean response if you are not logged in, the count, meaning the number of responses, and the full response or the full stored metadata that we have on this variant. So in summary, the Beacon v2 is an API specification. The Beacon 2 reference implementation is a Linux-based software developed by CRG. So we will have a couple of steps. We'll have the data ingestion to a non-SQL database and put an API on top of it. We will now use the Seneca dataset to try to create our own beacons. And the beacon-friendly format is a set of 7 files, which are just JSON arrays that match the Beacon v2 models. So how we've used the beacon reference implementation at the EEJ? We have a number of synthetic datasets currently available to download from the EEJ, and we have already beaconized the Seneca dataset, which is the one that we will use right now. We also have available the RD Connect one, and we are working on the Genome in a Bottle dataset. So finally, please allow me to thank everyone, and feel free to contact us with any more questions. Okay, so let's go and try to create our very first beacon. So for this, I will share with you this document. I think I can share with you. Okay, so yeah, here we go. I think this document has been shared with everyone. Okay. Oh, okay. So, and this. Okay, so. Oh, perfect.
I'm
Okay.
sending it, Mauricio.
Okay, thank you, Babita. So we will use this document as our guideline for starting our very first beacon. For the purpose of this beacon, we will create the beacon-friendly format, both the metadata and the genomic variations. We will start in a container our Mongo database, and we will also start the API. And then we'll be able to run some queries against this API. Oops. Oh, here we go. Okay. Yeah, so we will be able to run some queries against this API, and we'll be able to see the training UI sitting on top of the Seneca API. So some relevant links before we visit this workshop. So there is some multiple documentation. Oh, I cannot. Oh, here we go. Okay, so there is multiple documentation available. So in this documentation, we see the framework documentation. This was the very first link into the document. So a bit of an overview of what is the beacon. Here, in the second link, we have the beacon reference implementation, which is the one that we will use during this workshop. And finally, we have the Beacon v2 documentation, as in the framework documentation, where we can learn more about the specifications, about different beacon types, beacon models, beacon framework. So I do recommend visiting all of these 3 documentations. However, for the purpose of these workshops, these have been reduced to a number of commands that we will use to create our very first beacon. So for the purpose of this workshop, we need to have ports 5050, 8081, and 27017 free for running the Beacon API, Mongo Express, and Mongo database. So initially, we had considered this workshop as a bit more interactively. We would divide all our users into groups, and we would work in groups, meaning Group A and Group B. However, due to the format of the ECCB presentations, I will have to share my screen, and we will go through this documentation. So initially, we had considered a Group A and a Group B. A Group A would be a group that would have its own data, and it would be, yeah.
Is it possible for you to zoom in the document? I think that some people could be seeing it a little bit too small.
That's a nice idea. Here we go.
Yeah.
I think we should now. Yeah. No, thank you, Jordi. So initially, we had considering splitting the two groups. So what we will do right now is we will work as Group B, and we will work with the test datasets that we have prepared for you. So I will share my screen. Oh, sorry, I will share my terminal. We have some initial data that has already been prepared for you in a container, and we will request you to connect to that container. So the way to connect to that container is you just have to execute this command. So we're going to SSH into our ECCB demo container, which has 25 CPUs. It has roughly 80 gigabytes of memory. And each user will have a username and a password, so you can check it within this list that you have here. So I'm going to connect to the container using my supplied username and password. So let's go here. I'm going to use so just change this. I think I will be user. Let me go here.
Mauricio, could you please, the terminal as well, zoom in?
Okay. So where am I? I think here we go. So I'm user 37. Okay, so I need to change this thing. So what we are doing is we are connecting to a machine that is hosted at EDA. And this machine is actually the container that we are providing here to Group A. So let me just go here, get the password. I think this is it. Yeah, perfect. And now my user password, which was user 37, I think. Here we go. Perfect. Okay, so I'm inside the container. We'll wait for a moment so that we can all enter. And meanwhile, I'm preparing the next command. So each user is going to have its own working directory. And I think that it starts with an empty directory. So the next step into this workshop is for us to clone the Beacon Array API. So for this, I will use this ECCB workshop, and yeah, exactly, I will use this ECCB workshop, and I will just do, yes, I have some demo files. So I will just clone the Beacon Array API.
Mauricio, could you also make this font size bigger?
Of course.
And let me say that you will see a little of choreography moving from one machine to another, but this is just that we try to make the workshop possible for more than 20 users at once. So we need to distribute the load between your local machine and the machine, the server we have provided with some data, big data especially, and so on. So you can do that. But in real life, you will not need to do that much juggling from one machine to another. You will run everything in the same machine, and most of these commands will be not really necessary, and you simply will run it, and that will be all.
That's right. So the next step is for us to modify the conf.py file, which is inside the folder deploy. So we are going to go to beacon, deploy, and this file, it contains some preset configurations. And in our particular case, we are going to modify. So this is some general beacon information, but what we are going to do is we are going to modify our database host. So instead of pointing to our local host, we are going to point to the Mongo container that we will start up in a minute. So in database host, we will modify our local host to Mongo, meaning that the API is going to connect to our Mongo container, which we will start up here in Docker Compose. So now the next step, we will use Docker Compose and start up sorry, let me just say something here. Okay, so I have no containers running in this machine. And what I will do next is I will start my database. So I'll start the Mongo database. So we are just pulling Mongo 5. And here we go. So if we now just do docker ps, we should have an instance, a container running detach, import to 7017, containing our empty Mongo database. The next step that we will do is we will start Mongo Express to be able to peer, to view our Mongo database. And we'll start this in port 8081. Here we go. So we should be able to have here, that's it. So we have Mongo Express and we have Mongo 5. So we will use just Mongo Express to be able to view our database. To do this, we should now have a local host port 8081 on your browser type localhost 8081, and we should be able to view our beacon database, which is currently empty, as you can see here. However, we now have the models, the beacon models loaded inside this database. So the next step, we are going to connect to the virtual machine that we have prepared, and we are going to start the metadata transformation. So for doing this, we are going to use the Seneca spreadsheet that we have previously populated with metadata. These files, they can be obtained. Let me just move a little bit up on the document. These files, they can be obtained from the GitHub page, where, here we go. So the Beacon Array Tools page, and the template and the Seneca file can be obtained from this GitHub repository under the Seneca. And here we can find more information on how this dataset was created. So basically, we have taken a raw file that was distributed by the Seneca project that contains rich synthetic metadata, and we have mapped this file to our spreadsheet following the beacon models. So our next step is to go from a spreadsheet to beacon-friendly format. So what we will do is we will use the utility called beacon-friendly format validator. So let's go a little bit down on our documentation, and here we go. And this file has already been prepared for you. So you should be able to access it inside the container that you have connected to. So in this case, it's this container. Sorry, it's the ECCB container that you should have connected to via an SSH. So what we will do is we will run the BFF validator. We will pass as the input parameter the Seneca spreadsheet, and we'll just output the result to the folder where we are. So what the tool is doing now is it's validating the content of the spreadsheet against the reference schemas for each of the beacon models. So we expect we expect 6 different files. This will be the beacon models .json. I think that we have some usage in the cluster. Go. Thank you. If you have any doubts while we are performing this workshop, please drop any comments during the comments box, and Babita, Jordi, Aleix, or Arnau will be able to view and attend them. So what we have done here is converted our spreadsheet format to a beacon-friendly format, and we now have the beacon models that we declare in the Cineca spreadsheet. So this is the expected output. Let's take a look at one of those files. For example, let's take a look at analysis, and let's view it line by line. So this is in a JSON format, and this is the information that we have detailed in the spreadsheet. So we have just serialized a spreadsheet to a JSON format. So let's move forward with the presentation. If you need to catch up on these files, we have prepared them for you, and they will be available from this public server so that you can download them. Now, following up the transformation of the metadata into the beacon-friendly format, let's transform our VCF into a genomic variance format. So for this, we will use, here we go. So for this, what we will do is we will use the beacon utility, and we will pass as parameter our 1000 genomes testing dataset, which has 1001 variants out of chromosome 22. And we will also pass as a parameter in the file param.in. We'll take a look at that file. So for the purpose of this workshop, we have just in the parameter in defined the reference genome for this file, which is HS37. Let's see if we can take a look at the parameter.in. Okay, so I think that I have the path here. Perfect. Okay. So this is the content of our parameter.in file. It only has the non-optional attribute, which is called the genome. So you have to specifically state your reference genome. However, if we go here to the documentation of the beacon2 array tools, we can see that we can pass. So here below, a little bit below, and here we go. So this is an example of a parameter.in file where we have not only passed the genome, but we have some other attributes. Like, for example, where is the analysis? What is the name of the analysis that we want? What should be the metadata directory to check on this on the beacon models? And the name of dataset ID, and some other parameters that are described within the documentation. So for the purpose of this workshop, we have only stated the genome for this project, the reference genome for this project. Here we go. So the conversion has already run, but please keep in mind that this is only 1001 variants. So we have transformed the VCF, we have serialized it into JSON. So if we go here, we should have our folder called beacon and generated by a set of random created numbers. So if we go inside this beacon folder, we will have the log that keeps a record of the application log, and also a folder called VCF. And in VCF, we have our genomic variations, which is our the output that we now need to populate the genomic variant in Mongo database. So what have we done with this script? So if we go here to the GitHub page, we are going to take a look at the code, and we go to bin, and what we have run is we have run VCF to BFF. So this is what we have done to serialize the our VCF. So we have run BCF's normalization. So basically, we have left align indels and split multi-allelic to biallelic sites. And then we have started the annotation. So we are running a snipf with no statistics. And then we are going to run a snipshift with dbsnif, dbsnipf, cleanvar, and cosmic. And then we are going to parse and serialize the output of these three annotations into the beacon-friendly format file, which we'll take a look at right now. So this is why we have the initial file, then the file annotated with dbsnif, dbsnfp, then with cleanvar and with cosmic. But our target file is the genomic variations VCF. So if we take a look at the content of this file, we should see the variants line by line, identified by a unique value, that we will now load into the Mongo database. So we'll see that line by line, we have the variants. Okay, so let's continue here with our agenda. Here we go. So now what we will need to do is we'll need to copy these files that we have created into our local machine, because this is where we have started our MongoDB and our API. So we are just going to copy into this folder that we have created called demo files. Where is it? Here we go. Yep. Okay, so I'm just going to do something like data, and I'm going to copy the files that we have generated with my user. I think it was user 37. Let me just confirm this a little bit. Yeah, that's it. So I'm user 37. And here I am, user 37. And now I'll change this path for the correct path, which should be here. Okay. So this is the path that I want. Okay. So and I'll just pull the genomic variation files to my local computer. So what was my password? My password is ECCB demo. And my user password is, here we go, this one. Okay, So now that I have the genomic variations, I will execute the same command, but I need to pull the JSON files. Which means that I need to go a little bit down on the document. Here we go. It's where? Here we go. So I need to pull my everything.json. Okay. So it's here. And I will pull all of the JSONs that I have generated. So ECCB demo is, oops, ECCB demo is here we go, this password. And my user 37, it's this password. Okay, so I've pulled the 6 different beacon models that we have serialized from the spreadsheet into my computer, so we should see it here. So the next step is to uncompress the genomic variation file. So let's go to this step in the documentation that we have prepared for this working session. So let's just uncompress the file. And finally, we will start the load of the data into our Mongo database. So to do that, we can either do it 2 ways. We can use the loading utility that is distributed through the beacon array tools. But for the purpose of this workshop, we are going to use Mongo import. So we are now going to import all of the metadata. That's it, all of the metadata into Mongo. So here we have done, we have imported all of the beacon-friendly formats plus the genomic variation into the Mongo database that we have running inside the container. So this means that if we go to our Mongo Express, and if we do a connection again, if we just refresh our browser, we are going to see that now we have roughly 15 megabytes of data. So if we take a look at our analysis, and if we take a look at this document, we will now see that this metadata has been loaded correctly into the Mongo database. So the very final step is now to lift the API. So let's start the API container running detached. Oops, apologies. I have to go now to the beacon to array API folder /deploy. Now I need to start the container for the beacon API. So let's pull the container. Okay, so it started up running detach. So here we go. So this is our container that contains the beacon API, and it's running on port 5050. So now if we go to our local host, if everything went okay, I need to go /API. Here we go. So we now have the beacon API on top of our Mongo database. And the beacon granularity that is set in the configuration file for this beacon is record. And we can now see some metadata information within our beacon model, such as, for example, the biosamples IDs or, I don't know, the individuals. Sorry, let's go a little bit down. This is already in the individuals. So if I go here, individual. So, for example, individual IDs. So, what we have done here is we have deployed the API on top of the Mongo database. Now it only makes sense to try to do some queries. So if I want to learn more about this specific individual ID, I would just type individuals, individuals, and I would query for that particular ID. So this is the information that we have loaded, that this beacon can reply for that particular individual. So this is the rich phenoclinical metadata that we have converted from the Seneca to the spreadsheet, from the spreadsheet to the beacon-friendly format, and now loaded it to the Mongo database. And now, with the use of the API, we can share this valuable information. Okay. So finally, it's time for some beacon queries. So we will do some local beacon queries, meaning on our local beacon, and we will also query against the Seneca API, which has a more comprehensive dataset other than the small dataset that we are using. So for this, we have prepared a subset of queries that you can just pull to your machine. For example, I'm going to pull them in data. Okay. So I'm going to pull them here. Actually, no, I'm going to do this thing. I'm just going to do queries. Yeah, and then I'm going to pull them here. So I'm going to pull the very first query, which we're going to request the. Oops, what am I missing here? Oh, why is it? Oh, yeah, okay. Okay. So I'm just going to pull this very first query. It's going to return us the number of all variants. So let's query our beacon for the total number of variants. Here we go. So this is the count and of the number of variants that we have. Now let's, for example, try another query. And let's ping to a different beacon. Let's use the Seneca beacon, which is the public one that has been loaded with the Seneca dataset. So let's take a look at an SNP region. So let's just pull this file, and then let's see also the content of that query. So let's just pull this file. So it's request SNP region. Go. So this is a beacon query, and what we are doing here in our request parameters is we are setting up a start and an end position and declaring what is the variant type that we want. So what we'll now do is we'll run this query against the Seneca beacon that has been loaded with all the variants of the dataset, not just this small subset that we are using for this workshop. So here you can see we have six variants that are within this region. 6 SNP variants that are within this region. So let's modify this query and let's do this in real time, and let's request a different granularity. So currently, I think that we are requesting count granularity, so just the number of variants that we have, but let's request more information over that for those variants. So let's edit this file. And let's change the requested granularity because our beacon is the Seneca beacon that is hosted in the EGA, can reach the maximum level of granularity, which I have now forgotten. Record. Yeah, so the name is record. Here we go. So we can go on a record level. So let's request all the information about these 6 variants that we have found between these positions. So I really hope this works. Here we go. Okay. So we now have our 6 results, but we now find the rich detailed information over those 6 different SNPs that we find between the start and end position that we have requested. Finally, we can do this not only from the API point of view, but we can build a UI on top of this API, which we have shown. So this is the beacon training UI. And we can, this has been developed by Marta Ferry. And we can run some different queries and get initially the Boolean responses. We can, for example, become login users, which is just a fake button. But we can also get the counts and the full response from the beacon. And once again, here we are using chromosome 22 for the 1000 Genomes project. I think that Jordi has already showed some of these features, but we can search for a region as we have done in our API. So I think that we are authorized users. We have 12 results within this start and end position and the full response. And finally, on some phenoclinic information, as Babita showed on her presentation. Let's just use the very first query example where we are searching for a specific ethnicity from a specific country with a weight above 50 and the height standard above 150. So how many results do we have with this query? So we have some results. We have 60 samples with this query, and we can see the full response or the full detailed information over each of these users. So I think that is it from my side. Exactly. So this is it from my side. Let me know if you have any comments or if you have run into issues, as we'll be very happy to help you lift up your own beacon. So let me stop sharing. Yes. Okay. Yes, please put us in the main stage.
Thank you, Mauricio, for completing the entire set of instructions. Are there any questions for us?
So I see that there are some in the discussion forum and in the presenter chat.
Mm-hmm. Mm-hmm. Sure. Yes.
Babita,
Yes.
can you drive the audience on that, please?
Sorry, Jordi, can I what? Uh, So we were expecting, so we prepared the documentation in both case scenarios. So one was group A, that people who have their own data set, and there were group B, that we provided virtual machines for people who wants to work with test data sets. So I see, yeah, there were no private data sets, so everyone was looking for to work with test data sets, I guess. Mm-hmm. That's good. That's good to know. Okay. I mean, I would like to know somebody who said no, like what are the limitations or what did they find? I mean, it will help us to prepare the documentation better. So if they can send us chat or some way that where was it not understandable?
Now that you are asking that, everyone
Yes.
is able to do that.
Yes, I see that. Okay, no, there is.
Yeah, yeah. I'm trying to answer questions in the discussion forum about lists of beacon, because Babita has introduced this wonderful idea of the genomics, Internet of Genomics. This is fine. Actually, one of the successes of Beacon B1 was the Beacon network that has more than 200 beacons on it. And we expect that this is happening again with Beacon B2, indeed better. But in Beacon B2, we have fostered also a lot that Beacon is used for private purposes, for closed networks, for sharing information data between partners that trust each other, not necessarily publicly at all. And one of the first examples I explained several times already is that when we started requesting details of what Beacon B2 should be, one of our interviewed institutions said, we would like to have a beacon inside our hospital to communicate three different departments that all of them are sequencing, but none of them is sharing that information because they don't have the tools. So this could be a totally private beacon only for people that already has access to these electronic health records, and no one will know that this beacon exists. And we want this to happen. Global Alliance want this to happen a lot, because what we are providing are standards for sharing data, not necessarily sharing data with the world, with humanity, with the ones that need it and that could do a good use of it, both for the benefit of the patients or whoever could benefit from that. Okay. Having said so, uh, we expect that most of the beacons in Beacon Network B1 move to Beacon B2. Also, LXZ is preparing a Beacon network that I don't have the address in my memory, but I will look and pass it in the discussion anytime soon. And also, the Global Alliance is because of that the typical question that we get in the chat, a list of different service implementations of different services they have, not just Beacon, but others too. And they were preparing that. I think that if this is not public yet, it's because it's not done. And my expectation is that they will do a public announcement of this thing as soon as it's ready, because this is something that benefits them a lot. So sorry, because the scenario is a little bit complex, and it's not the easy, straightforward answer for that. Yeah. Okay. I will pass the URL of the Beacon network there.
Okay.
So most of the things that Mauricio has shown and that has been prepared by the whole team is if you review the steps, you will see that maybe 50% is setting up the servers required for doing this. Yeah? So if your beacon exists, or this will be done just once, that will not be necessary to be done The only part that could be done is you loading the data inside this beacon. And of course, if you have done the deployment, you will also have the beacon API ready. So you only need to load the data. And loading the data is quite straightforward in this case because this is data that is prepared for that. We have done tests with some other data sets, and they are quite straightforward too. Okay? So probably the more complex side of it is populating this thing that we call the metadata or the phenoclinic data, the list of individual samples, experiments, and so on, that you need to translate from the data that you have to something that makes sense in an interoperability scenario like the one Beacon is living in. Okay, so that would be probably the investing time. I would say that in this type of projects where you need to do these kind of things, usually what we call the ETL, the extract, transform, and load process, takes 80 or more than the time devoted to the project. So if you want to data warehouse or any other thing like that, your time will be mostly invested in transforming the data in a way that could be used by that. And I think this applies to OMOP and other initiatives that are around for sharing or for reusing information, phenoclinical information. Okay, so with that, I will shut up and allow for some more questions and try to find the URL of the LXDB network quickly.
Well, there was one more question, I think, Jordi. It was somebody's asking if Beacon's search engine cache or store data on your site when you send any query to public Beacon providers. Jordi? Yeah.
Now, one second, I was looking for the URL of the LXDB network and trying to
Okay.
understand what you are saying at the same time. Mm-mm.
No, it's okay. You search for the
No,
URL.
no, 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 no. The idea is that beacons doesn't need to, of course, it depends on the implementation. In the case of the beacon reference implementation, is caching nothing. Yeah? The only thing that we suggest the beacon network clients, the aggregators, to do is to cache the metadata about the beacon. So which are the endpoints supported, the granularity supported, the filtering terms supported, but nothing about the data itself. Yeah? This is a clear answer. However, every implementation could be as they see fit. So if after tomorrow, I don't know, Spain decides that it will create a beacon network on top of the research data in Spain, and they decide that this will be cached, of course, that will be the legal or agreement parts on it, but that could be possible. Sorry, my contact lenses just moved, and I'm suffering right now. One second.
Okay. So maybe we can move to the next question by Maria. So she says, I have been playing with the Beacon RI tools today. My problem is that I don't know how to fill the case level data in the genomic variation.json. Because as far as I see, the values there are the ID of other tables. For example, having the individual ID, yes. Do I have to do it manually or there is an automatic way? So the thing is for the first optimization, many of the process of this mapping is manual, which is a bit painstaking. But once it is set, or you know how to map or where to map, you can make the pipeline or automatize it. But it's on your side, that I would say. Mauricio, you have anything to add?
No, I think that's it. So the more complex part is definitely the mapping of the metadata to this spreadsheet, or even going from metadata to JSON format without this intermediate file. But this will be the more time demanding part of setting up your beacon, is converting this metadata. Once you know what fields to populate and how to populate them, you can do it programmatically.
So, and in some projects, we are working on trying to avoid moving data to Beacon as much as possible, because this is the goal. The goal of Beacon is not to have another copy of the data unless you want that. If you prefer to have an isolated copy of the data for security purposes or whatever is the thing, that makes sense. But if you don't want to do that, we are trying to find ways to connect to mob services, for example, and so on. So this could be done hands off, kind of, in that case. Yeah? Okay.
So there is one more question from Rizwan. Can public variation tools like Protvar import data provided by public beacons? Mm,
1 second, I'm looking into this prop bar thingy.
or in general, I think the question is, can any other database import data? Can they import data from public beacons?
Sorry, this one, I don't really understand what is the question. Yeah? So if your data is public in any beacon, then given that it's public, is like any other thing that you can query in internet. Okay? So if you are looking for, I don't know, the list of the discography of the Beatles, then you can find that information. Yeah? And actually, when I described Beacon Network version 1, the Beacon Network version 1 was exactly doing that. Is the beacons were not aware, let's say, that there is a beacon network querying them. The beacon network just has a list of beacons, and it pings, queries the beacons one by one, let's say, without the beacon being having to do anything. It's completely hands off for these beacons. So if the beacon is public, that's the goal of the thing, that anyone could discover that information querying that. Yeah? So I'm still not having the Elixir Beacon Network URL that I should have quite close, not having it yet. It's not difficult to find. Eh? So this is it.
Okay. Okay, fine. Thanks, Robert. So there is this beacon
Yeah, the
network.
question about the how to showcase, given that we are maintaining the list of beacons that in that service registry, you send an email to us, to Babita, for example, and we will add you to the list of these things. The verifier, you can run the verifier on your own. Actually, is the recommended way of doing that. That you download the verifier from the GitHub repo, you run it on your beacon, and you see the results and which are the things that are the verifier is complaining about, and so on. Yeah? But remember that the verifier is not the truth. Yeah? It's not the law of the universe. It's one way we did to interpret what the API should be doing, and so on. So it could be mistakes and omissions in that verifier. So don't assume that if it throws an error, most of the times will be real. Some cases we had some discussions with some implementers about if the interpretation of the specification should be A, B, or C in this respect, and then we, in some cases, we should amend the verifier for that interpretation that is also valid. Yeah? So I don't remember the end result of the poll about the if them being all of them or almost all of them able to do the steps on their own.
Yeah, so there were 14% of the people who said no, that they couldn't follow the documentation. But yeah, the question was what step. It would have been nice to clarify that, and also that we understand this format for hands-on session was not suitable. It would have been much better with on Zoom sessions, for example, or in face-to-face one-to-one sessions. That would have been much better to explain. So we are open for more sessions like this, or you contact us and we can explain the doubts, etc. So we will be more than happy to address that.
Okay. So in my understanding, if we have no more questions, we can wrap up here.
Mm-hmm.
Yes. And again, thank you for attending the beacon. We know that we are providing the tools and little by little providing more documentation and these kind of hands-on sessions and so on, and providing these exercises so you can try to replicate these steps on your own and then start testing with your own data or with any other data that you would like to use for testing and so on. So keep asking us both in person, both by email, and of course in GitHub. That way everyone could see the questions and the answers and benefit from it. Okay, you want to wrap up, Peter?
Yeah, well, thank you again, everyone, for joining. This was our first official Beacon hands-on session after the approval by G4GH. So we were also looking forward to this. We welcome you all to write us or contact us and invite us to your institute if you would like to have this at institutional level. We will be more than happy to come to your place and give a workshop. Thank you, everyone. Thank you, Mauricio. Today, you were wonderful providing this hands-on session. Thank you, Jordi. Thank you, Alish, Arnau, and Lauren, who were at the back helping us, and the help organizers of this workshop. Thank you so much.